Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna share with you this setup that I did. I call this one like an abnormal pie. Previously, in the previous live noding, I made this kind of like a normal pie chart. But this one is kind of similar to that, but it's slightly different. Instead of having pie that's being sliced evenly, this one actually takes any kind of data that you pipe it in. Imagine if you have like some kind of data with different numbers and you want to put it into the pie, and normally that's kind of how the pie chart works anyway. So I thought this can be kind of easy to explore, and this is what I come up with. If I create the edges and display the edges, you can see what's going on, and if I display the points, it's a bit clearer. I'll hide it again. I'll probably make it into less number, like 24. Now we have this. This is actually, everything is a bit random. I'm not using like a real data for this, but they are random, but there's some kind of system underneath. So if I play around with the parameter here, I can adjust the scaling. Actually, this scaling thing is just an extra thing. You don't need that. This can be just like a normal pie, but I make this so it looks a little bit more interesting and a little bit abnormal. But normally a pie chart is pie chart, you know. But imagine this pie chart is for, let's say, even 24 is quite a lot. 12 or 8 type of data or 5 types of data, and then you want to kind of provide a list of 5 values, and this is what you end up with. Maybe this is the number of people who are using Blender, it's the number of people who are using other 3D package, and you put that data into a list and you get a pie chart. So this is a pie chart. It's not like super abnormal, but it's abnormal when we kind of increasing this number and kind of doing this. So it's kind of cool. You can randomize it as well. Maybe use this as a musical visualization. I don't know, at some point I really want SphereTalk to be able to generate some sounds, and we can use some kind of abnormal geometry and turning geometry into music. Maybe that's an idea. So I'm gonna save it again because I like saving blend. Okay, let's start from scratch. I might not start from scratch. I'm just telling you the story how this actually works. So similarly to the pie chart where we make like a evenly divided pie, this one start with a circle, as you already know. In this one, it's automatically, first of all, I'm preparing like bunch of data. Okay, the data is actually random. So in this case, I have 20 data. Let's make it smaller, even smaller, like 5 random data. Don't worry about the scaling. Yeah, maybe I turn off the scaling for now. So just 5 data, and I randomly generate data between 0 and 1, and the value output that I'm getting is this value, just random, 5 random number, 0.3 whatever. I can actually increase this to any kind of data. It doesn't matter. The pie chart here will adjust accordingly, and you'll still get like a working result. So this is how interesting this setup is actually is. So any random number will work, but I'm using number between 0 and 1 just for simplicity. And this is the random number that we are getting, 0.016 whatever. This is 5 random number, doesn't matter what it is. And the next thing what I did is to sum and make a total of those number, and this is the total number, and this can be any value. But I'm kind of the next thing I did is this normalizing the value. So whatever value we have, so we have 5 data, right? We have this and we have that. Imagine this is like the total, the number, and then I divided every single one of this number using the total of all of this. and what we get is going to be like some kind of normalized value. So it's like with a normalized value, if you kind of sum all of this value again, the result will be 1. Okay, that's what I mean by normalizing all the value. So we have like kind of not the average, but kind of you have each and every value divided by the total number, so you get the kind of like the elements that makes a whole. So that's actually perfect for our pie, because the pie, if you slice it based on that value, like a normalized value, we're gonna get, if we put them all again, we're gonna get like a proper 100% pie, the whole circle. So I'll randomize it again just to get a better value. Okay, that's good. Okay, what's next? List mass. This is okay. This is actually not very necessary. This is just to test it. So say the sum is actually 1, so that's not important. Once we get the value normalized, this is the normalized value. Okay, we don't need to see that. What's happening next is actually more interesting. This is execute node mode. This node is pretty interesting. If I actually make it execute node mode, this is how the nodes looks like by default. It has an example for I and I2 in zip, v1 and v2 append, blah blah blah, and there's an output. This is kind of a node that kind of if you have like a formula, some kind of functions you want to, I think, to generate any kind of functional kind of Python code will actually take some inputs and gonna output a result right away. So this is kind of very interesting nodes. It's a bit advanced, but I really like it. In this case, I got help from, I think, cost4. There's this formula. It's an append. Append is a Python formula, and then there's this NumPy array. NumPy NP is usually NumPy. It's part of a Python included in Blender. It's like some kind of module that deals really well with array of data. So Python normally deals with list, but NumPy deals with array. Like in a really, it's really fast, I think, for scientific calculations. But anyway, NumPy module has the sum, the cumulative sum functions that actually, in this case, what I really want is actually, you know, that we normalize the value. Okay, we have 5 different value, random value, and then we already normalize it with the total. And I told you that already, if we total all this normalized value, we're gonna get the total of 1. And with a sum, I want to get, say we have a number like 0.1, 0.2, or actually just make it like a full number, 1, 3, 5, 7, 12. We have this number, and we divide each and every number with the total of this number, like 4, 9, 16, 28, divide everything, and the total will be 1. But with a sum, this a cumulative sum, we can have a list that's actually 1, 1 plus 3, 1 plus 3 plus 5. So this is cumulative in math. This is very, very useful if you kind of like make a division or parts of the whole, and you want to kind of imagine you kind of adding each parts little bit by little bit. Let me kind of think of another way to explain this. Okay, you have 5 glass in different size. Each one of them has water, and you want to put it into a bucket, and you want to put it one by one, and the bucket will fill up itself a little bit by a little bit. So if you imagine this bucket as a pie, and if you fill it up a little bit by a little bit, soon enough you're gonna get the full pie. That's what actually the value that's I'm trying to create. So anyway, this is the cumulative value. You can see here 0.26, and the first normalized value, and the next until it gets to 1. Okay, and apparently here I'm multiplying it by 360 because we want to kind of map the value back into the something that can make the whole pie. You probably need to watch my previous video, which is much simpler, where you know, for this pie, you know that it's actually based on a circle, and we know that the circle can generate a single pie, and the first pie will look something like this, and this how many degree, like maybe it's like 30 degree, in order to make for like a for previous live noding, for like a pie that's divided perfectly, 30 degree can goes around a circle and makes like a 12 pie. If we have like a pie that's like 60 degree, then we have like 6 pi. In this case, our pi is really like a bunch of random numbers which we already normalize, and we have this sum, the cumulative sum, and etc. etc. But anyway, in the end, we really did exactly the same that we did in the previous live noding. So we just simply rotate the pie. We generate the pie first based on the slices, like normalized slices, and then we kind of rotate. We know how many degrees that it's actually each of these abnormal slices is needed, how many degree we know, and how many also how they're gonna rotate from the original pie, because without the rotations, if we look at it, if I cut this matrix stuff, this is what we have. Okay, look at it from the top view. This is what we have. If I get rid of the face, you see how many we have. 5 pi. There's one really big slices, and there's a smaller one, and there's a smaller one. So there's this is the biggest pie, and there's a smaller one, and there's this one and this one. Each of them already have like the degree, like a some kind of ratio that, but if we put all the pie properly using the rotations, we're gonna get a full pie, like the full circle. Yeah, so that's the idea. It's a little bit hard to explain, but yeah, we got it. We only need to worry about the degree. Actually, this, like I said, this random number for the radius is just an extra thing. We don't need to do that. This radius can be just a single value. The degree is the one that's matter. The degree comes from this one. This is the degree of rotations, or actually this is the degree of the circle, part of the circle. It comes from this this normalized value, and it's being remapped from 0 to 1, remapped back into 0 to 360. So that's the for each and every pi. However, the rotations need to be like an accumulative value. For this, I actually have this value from here. This is an accumulative value, and actually I multiply this by 360 and I shift it by 1. Yeah. If we have like a in the previous live noding, like I said, if we have like a pie that's kind of, we have circle that's kind of 30°. For the next one, we gotta rotate it 30° again and 30° again. That's very easy. We don't need to use accumulative. But in this case, our pi, perhaps the first one is like 10. The next one should be whatever the degree of the circle. It should be 10 plus a value, right? Any degree. And then the next one should be 10 plus 35 plus another number, like random number. And we do it, all of this all at the same time using the Spreadchalk, this all procedural generators. And but I think the most interesting part is really the sum, the cumulative sum. Yeah, that's very important concept. We don't actually need this either. I can just frame it. Just keep following. I'm gonna give you this node tree anyway. You can study this, play around with the value and see what you can come up with. If you want to make it pretty, of course you can increase the number of random value. Actually, let's make this random value a little bit like crazy values, 10 and 60. If you really want, you can actually see all the numbers on each pie, and so it's become more like a pie chart. But pie chart itself can be a little bit boring. So if you randomize the radius of the circle and make it a little bit crazy like this, this is more interesting, right? A lot more interesting. And let's make it, how many numbers? 36. So we have 36 value goes into this guy, and now we have a really cool looking pie chart. We can control the minimum and the maximum radius of each pie, and you have this. And if you, at the moment, of course, you can, if I bake it, we're gonna end up with a 36 objects, but I don't care. You already know how to join them in Spreadchalk. I'm gonna bake it, and here I'm gonna join it. And what else can we do really quickly? Solidify. Now this guy's become like a 3D object. Bevel. Well, actually, I just make a bevel really high number. That's actually the thing with need to be careful with in Blender. Sometimes big number, and then it needs to calculate the whole thing. We cannot cancel it. But anyway, this is kind of the continuation of the previous live noding, where we have like a equally sliced pie. This one is a little bit more crazy. This is like the abnormal pie, but this can be more